In section 1.5, we are now graphing. We're going to start with just sine and cosine, so graphing them as functions. First, I want to show you an animation that you actually have access to through WebAssign or through your ebook. It's in 1.5 in the lecture videos under the WebAssign resources, or in the textbook. It's just right in there in section 1.5, and you can just click it from there. But you can start by graphing sine the same way that you would graph something like x squared, where you make a table of values, you choose some x values, you plug them into the function to get the y's that go with them. So here we would choose angles, and usually the common angles that we can evaluate pretty easily. And we'll plug them into the sine function. So the input is these angles, and then we're evaluating sine to get the output. And we've already seen the pattern, and we know how the y values repeat, and there's that pattern there. And when we plot that on a two-dimensional coordinate system, we get a wave. So the graph of sine, where the values are repeating, they're just changing sign. So our graph is a wave. So we can get this just from plotting the points that we have on the unit circle of the special angles that we already know. So drawing a curve through those all together, we get the sine wave, and it just repeats infinitely. So remember the domain of sine and cosine, where all real numbers, you can plug anything in there, as these angles, just keep going and going and going forever, infinitely. You can plug anything in, but your y values are just going between -1 and +1, because those are the only outputs that we get from the sine function. And you can see that this wave just repeats. So after we get to 2 pi, everything is exactly the same for another 2 pi, and the curve repeats every 2 pi. So that is the period of this function. How long before it completes one full cycle, before it starts to repeat? That's the period. You may also find useful here the explore it. So in the lecture video section in 1.5, there's an explore it for sine in the unit circle, and it kind of allows you to explore the relationship between the unit circle and this graph that we're drawing now in 1.5, and kind of see the relationship between those two. So I encourage you to take some time to look through that. Okay, so now let's talk about some of the important features of this graph. As you've done with many functions so far, linear functions, quadratic functions, you'll find useful ways to graph them more easily. But when in doubt, you can always plot points. You can always just choose some points and graph them until you can see what the curve looks like. All right, so I'm going to make a table of x's and y's like we just saw, and I'm going to put on this chart a few key points in our graph. So you saw that the curve, it starts at 0, and then it goes up to its highest point. It comes back through 0, goes down to its lowest point, and then back to 0. That completes one full period of the sine wave. So I'm going to put on this chart our starting point, the high point, the midpoint, low point, midpoint. So those happen at 0, pi over 2, pi, 3 pi over 2, and 2 pi. So we can evaluate these. So the y values are just sine of these x's. So sine of 0 is 0. Sine of pi over 2 is 1. Sine of pi is 0. Sine of 3 pi over 2 is negative. On our circle, these are on the axes. These are the quadrantal angles. All right, so this 0, that's our midline. And then we've got our high point, and then back to the middle, and then our low point, and then back to the middle. So I'm going to sketch that. I want to at least put on my graph one full period. So from 0 to 2 pi. And I'm just splitting this period into 4 equal pieces. So if I take 2 pi divided by 4, then each piece is pi over 2. So halfway is pi. Half of that is pi over 2. Halfway here is 3 pi over 2. And then I'm going to plot these points that are on my chart. I've got 0, 0, pi over 2, 1, pi, 0, 3 pi over 2, negative 1, and 2 pi, 0. I'm going to draw a curve through those. And this is not the whole graph, so it continues on infinitely to the left and the right. So I do need to, at the very least, put some arrows at the end to show that it doesn't stop there. But this shows one full period of the graph. So some key features here that you want to know about the sine function. We talked about the domain, it's all numbers. The range only goes from -1 to +1, including -1 and +1. So that's why I'm using brackets. It takes 2 pi to complete one full period. This function, we talked about even and odd earlier. This one is odd. And now that we have the graph, you can start to see the symmetry. So remember, even functions have y-axis symmetry. Odd functions have origin symmetry, and origin symmetry is kind of a diagonal thing. So you think about this graph. If you were to fold it over the y-axis, and then fold it over the x-axis, this top piece, bottom piece down here would match up. So it would match up with itself. It's got that symmetry. Our y-intercept here is 0, 0. Only time we cross the y-axis is at 0, 0. And the x-intercepts, there are infinitely many of those, but they always happen at multiples of pi. So you sometimes see this written as k. So k is just some integer times pi. So it's going to happen at 0, pi, 2 pi, 3 pi, 4 pi, and also negative 2 pi, negative 3 pi, negative 4 pi. All of those will be x-intercepts. So this is the basic sine curve of just y equals sine x. And throughout this section, we are going to do some transformations on this graph. So you have done this with other functions like y equals x squared. You shift it to the left or the right or reflect it over the y-axis. We'll do all of those things with these trig functions also. But first, let's take a look at the basic cosine wave. Cosine wave is just a little bit different than the sine wave just because it starts at 1 instead of 0. But it still has 5 key points, and they still happen at 0, pi over 2, pi, 3 pi over 2, and 2 pi. But this time we're starting at the high point. So the graph starts at 1, and then it comes down to 0, dips down to -1, comes back up to 0, and then up to 1. Okay. And we don't necessarily need it. It will just graph on one period. But if I went to the left of my y-axis and I wanted to label those, they would start to become negative. So I would have negative pi over 2, negative pi. They would be off to the left of my y-axis. All right, so I'm starting up here at 0, 1. I am coming down, crossing the x-axis at pi over 2, dipping down to -1 at pi, and then back up to the x-axis and back up to the top. So cosine does more of this thing. And of course it continues in both directions. But this one starts at the top. So cosine is the same domain. You can still plug in any number, any real number. Your outputs are still going to be in between -1 and +1. Cosine is an even function. So you see the y-axis symmetry here. If I were to continue this graph a little bit more, you can see that if I were to fold it along the y-axis, left side and the right side would match up. That's y-axis symmetry. That makes this an even function, in addition to the definition that we had before. So this cosine of pi/2, this point here, should be equivalent to cosine of -pi/2. That's an even function. The y-intercept here, the only time we cross the y-axis is at 0, 1. So starting point there. And here for our x-intercepts, they're happening. So we've got one at pi/2, and then every pi radians, we get another x-intercept. Usually we'll write that as pi/2 plus multiples of pi. So pi/2 plus pi, pi/2 plus 2 pi. That'll give you all of the x-intercepts.